we live? I do believe that we are live. I think we are live now. Okay, we are live. Hello everyone. Welcome to today's lesson on Ionic Network Lattice and dipole forces. What class is this? It's chemistry. Anyway, welcome to class. Let me get my words up. Okay, today this is our scuffed assessment where we are looking at ionic network lattice and dipole forces. For ionic and network lattice, I need to find that piece of. We are going to be using our example of table salt for ionic network lattice. So, for salt, or NaCl, sodium chloride, they form this structure which looks like this, and I have built a virtual version of it. So I have built us some sodium chloride. Quite a lot of sodium chloride. A lot of sodium chloride. A lot of sodium chloride right here. So this is roughly what ionic network lattice looks like. And this is just with the salt configuration. Green is chlorine, purple is salt. Now you might notice that it kind of does actually look quite a bit like, what is it? These. Give me this. These. It looks like these things right here. Yeah, it looks like that. Which is kind of interesting. Those are the ones and thousands cubes thing. So this here makes a good connection between each element, when it keeps it all together. Now you can actually get this in the real world demonstrated when you have what is it? You know, when salt water solidifies and it forms this nice little crystalline, blocky looking thing structure. And so if you take a look back at the standard just straight up image of just salt, you notice that it all comes in those cubes. This is why, because the ionic network lattice is a cube. This is canonically why salt forms like this, okay? This is canonically why you only get salt in a cube. That's a joke if you can't tell, because funny, because why not? Anyway, so how does it actually stay in this position? Well, that's where it comes down over to here. So, now, this chlorine has more electrons in it than sodium. So technically, sodium is more negative and chlorine's more positive. So, we can use this for dipole forces. So dipole force is basically like magnets. And so how do magnets work? Like this. They attract the lesser end towards the positive, the north to the south. They don't do this. So yes, they attract like a magnet. And that's how that whole structure works. Because it forms like this. You can actually try this out at home with your own magnets and such. So if you notice that, you know, it's not at all connecting with that, this one here will not connect with any other sodiums. It's only connecting with its surrounding chlorine ones. And same with all of these as it goes on. So that is how that's how dipole actually is proved with ionic network lattice. I don't know. Maybe I'm wrong somewhere. Oh, that's where I'm wrong. I must have messed up my placement there. disregard that spot. Disregard that area. But yeah, any questions? Do we have any questions? We are opening. No, we have no questions. Thank you for watching. Wait, I'll just say now, questions. Do we have any questions? We have passed 5 minutes, so that is all the time that we have today. Thank you. Don't be mad about this going over the time limit at all, please. Thank you. Goodbye.